Nobody joined till now. So I think let us start. Welcome in week 12 hydraulic engineering PMRF live session. So I'm Om Prakash Maurya from Department of Civil Engineering IT Guwahati. So week 12 is about basically the introduction of the wave mechanics. Generally at undergraduate level, uh, this topic is covered very rarely, but in this course, the hydraulic engineering at introductory level, the linear wave theory is covered, which is the advantage of this course, hydraulic engineering. So, and all sort of conversation will cover or sir have covered for inviscid flow. Okay, so linear wave theory in week 12 the lots of topics are there. The linear wave theory, boundary value problem, derivation of velocity potential, and velocity, what is the velocity potential, dispersion relationship, and celerity, local fluid velocities and acceleration, water particle displacement, group celerity, pressure under progressive wave energy and power. So basically I will cover today lots of problems related to this topic. So your understanding of this topic will be very clear. So basically I have selected some questions which are very basic question in this topic, which will be help in your basic understanding of the terminology related to the this topic, and the advantage things you can get from the sir lecture, that is NPTEL week 12 lecture of hydraulic engineering. So we'll begin with our question answer session with this the end of your introduction of the topics. So now let me share the question answer session, the question answer, and where is the question, let me, yes, so these are the questions. So let me share, if somebody join, so it will be very helpful. Let me close first. Sometimes somebody join, then it will be very helpful for, let me check whether it is visible or not visible on Google Meet. So it's showing, yeah, so nobody is still joined. Okay, let us move ahead with the question and answer session. If somebody join, then it will be fine, otherwise session, I am recording the session. You can go through the YouTube channel of the hydraulic engineering PMRF live TS session. So now let us start. So the first question is very basic question. Other questions also are the very basics. So the first question, let me take the pen. So first question is, okay, what is the primary assumption underlying linear wave theory? So basically this, what is the assumption behind the linear wave theory? So option A is about wave are non-linear. Option B, wave amplitudes are small compared to the depth of fluid. Wave propagate at the same speed regardless of depth. Wave energy is constant along the wave profile. So these are the four options. So please, the all options, if you will see very carefully, let me show the figure first of all. What are the terminology? So in a wave, basically, the distance between these 2 points is the wavelength. Sometimes the distance between these 2 points is the wavelength. Sometimes the distance between these 2 points is the wavelength. Or you can say distance between these 2 points also the, or if you want to measure from here up to here. So this is the wavelength, and these are the point, whatever the below point from the zero, that is your level. This is the, if you suppose this is your water level in still condition, that is when the velocity is 0. So after some, due to the some let's suppose disturbance, any kind of disturbance, wave is propagate like that on the water surface. So whatever the this below thing, the crest point at the below, that is the maximum point at the below of your water level in normal condition is known as the troughs. The crest, the amplitude from your water level to how much higher is going, also the below one also. So remember, these are the terminology, but the question was that what are the assumption for linear wave theory, and what is the assumption? Basically here only one option is correct. So if you will see very carefully, just option B. What is telling the option B? Wave amplitudes are small. Wave amplitude means this one, A. Wave amplitude are small compared to the depth of fluid. Let's suppose, what is the depth of fluid here? Meaning, if your, let's suppose one pond is there, or you can say one channel is there, and water is flowing from this direction to this direction. Initially water level was up to that much. Due to some disturbance, your wave propagate like that. Wave propagate means what? Your water surface, this water surface reach up to that, this water surface, water surface is propagating like that. Your water surface is propagating like, initially was a straight normal condition, but so whatever the value of water depth is how much, let's suppose here y, or your amplitude of the wave is a, so your a should be less than y. This is the assumption of linear wave theory. So this is the first question. If you want to select the correct answer, the option B is correct for that. Obviously option A will be not correct, because here the non-linear thing is the wave propagate at the same speed regardless of depth. This is not the criteria. The wave energy is constant along the wave profile. This is also not the criteria for linear. So only option B is correct. Now moving ahead on the question number 2. So here you can say the explanation also. Explanation is what? The linear wave theory assumes that the wave amplitude are small relative to depth, that's good, of fluid, and this assumption allow the application of linearized equation of motion and simplifying the analysis of the wave behavior. So basically this assumption help in what? Basically linearize the equations. Linearize when you know already the non-linear partial differential equation like Navier-Stokes equation very analytically very hard to solve, or even to this time nobody can solve the no one up to that time no one solved still the Navier-Stokes equation for turbulent flow. So very difficult to solve the non-linear equation. So for linearizing the equations, that is your wave equation, whatever the equation, just example we will see in the below. So linear wave theory help us to linearize the equation so we can solve analytically very easily. Now moving ahead on the next question. Next question is about which equation governs the behavior of velocity potential. Here is very important. Velocity potential in linear wave theory. Anybody join? No one is still join. Okay, we'll move ahead. So this is also very important. So whether in linear wave theory, which equation governs the behavior of velocity potential in the linear wave theory? We are talking about velocity potential in the linear wave theory. Euler equation, Bernoulli equation, Laplace equation, Navier-Stokes equation. So just for your sake of understanding, what is the Bernoulli equation? P by rho z plus v square by 2z plus z square, z is equal to head. What is your Laplace equation? Laplace equation is nothing but del square. If I write in terms of potential function, x square plus del square phi by del y square is equal to 0. What is your Navier-Stokes equation? If I am right in the x direction, what is the for the unsteady? Del u by del t plus u del u by del x plus v del u by del y plus w del u by del z equal to minus del p by del x plus your mu del u del x plus u by del y plus del square u by del z. Here is also square, and if any the body force also if you want. This is your Navier-Stokes equation. And what is the Euler equation? Euler equation is nothing but it's a similar some integration form, because from the Euler equation we derive the Bernoulli's equation. So in the form of integration we get the Euler equation. So here is the question, just for sake of your understanding I have written here. So what are the velocity potential which equation governs the behavior of velocity potential in the linear wave theory? Please try to give the answer. Let me see your Euler equation first. I write this is a rho plus v square by 2g plus gz equal to constant. So these are the equations. So for sake of your understanding, the Laplace equation is used for uh, in the linear wave theory for the your velocity potential. So remember always. So option C is correct for you. So this option is correct. Now moving ahead on the another question. The explanation is what? In linear wave theory, the velocity potential is governed by Laplace equation which describe the distribution of velocity potential throughout the fluid domain and subject to the appropriate boundary conditions. So if you want to see in the lecture, I think sir has also described your velocity potential here also. If you want to see solution to the Laplace equation, basically this is the week 12, this is the week 12 your you will see linear wave theory and all. So here also sir has discussed lots of the your equations, wave equations, in terms of solving the your Laplace equation in the linear wave theories. So please try to understand with this material also. So now move ahead on the another. Anybody join? No, still not. I think nobody will be joined today. Okay, no problem. Now moving ahead on the next question. So here answer is visible, so no problem. But let us, okay. Okay. So what does the dissipation, what does the dispersion relationship describe the wave theory? Dispersion relationship, the relation between wave frequency and wave amplitude, that is F and A, the relationship between wave energy and height, wave energy and height, the relationship between wave speed, frequency, wave speed V, frequency and wavelength lambda, and relationship between wave depth and wave celerity C. Celerity is a very important in terms of your open channel hydraulics also. So when I have one celerity related question to the celerity, I will discuss more on that question regarding in terms of the open channel flow. Your celerity. So option number C is correct, as you have seen earlier also. The relationship between wave frequency, your V is equal to what? Lambda F. Or F is equal to what? 1 by T. T is what? We'll see in the further question. The relationship between wave speed, frequency and wavelength. The explanation is what? The dispersion relationship describe how the speed, frequency and wavelength of wave are related, and this it characterized how wave properties vary with each other, particularly in the context of linear wave theory. Always remember, wave celerity in context of, what is the wave celerity in context of waves? The rate of change of wave amplitude, speed at which wave crest propagate, ratio of wave height to wave length, depth of water at which wave break. So celerity in the context of waves. So here the question is about the wave celerity context of wave. So it's nothing but the speed at which wave crest propagate. So actually celerity, always remember in case of the open channel flow, celerity is nothing but your wave velocity minus the velocity of water. That is your velocity of medium, you can say here. If wave is moving in water, you can say here I am medium. Remember, if this is the wave velocity, your wave velocity basically having all these things. What is the velocity having the two things? What are the things? The velocity of fluid, also the velocity of your wave. Velocity of wave means whatever you have given the extra energy in terms of disturbance, that velocity also. So that's why your celerity is the velocity of water surface, the velocity at the water surface level, or you can say the wave, only due to the whatever we have given the external energy in terms of disturbance. So here you need to understand. Now moving ahead on the next question. So option B is correct for that. Option B is the speed at which wave crest propagate. The explanation: the celerity refers to the speed at which wave crest propagate through a medium. It represents the velocity of energy transport associated with the wave motion. Remember these things, whatever I was discussing that thing only written. Now moving ahead on the next question. Next question is, which factor primarily influence local fluid velocities and acceleration in wave motion? So why these are the basic understanding is required? Because of we need the boundary conditions and all. So when we apply the boundary conditions, these all these things we need to understand. That's if we will understand very carefully what are the factor which influence your wave and what is the celerity, and if you will understand some basic theoretical knowledge about the topic, then you can easily apply the boundary conditions. You can easily understand the flow behavior when the wave come in the picture. You understand the analysis, you can analyze in very well manner of the wave of water or wave of any fluid. So remember, so which factor primarily influence the local fluid velocities and acceleration in the wave? Wave frequency, water depth, wave amplitude, and the wave direction. So the answer of this question is wave frequency. Your wave frequency primarily influences the local fluid velocity and acceleration in the wave motion. So explanation is what? That is your wave frequency. Option A is correct. The primary factor influencing the local fluid velocities and acceleration in wave motion is wave frequency. Higher frequency result in the greater oscillation and therefore higher local velocities and acceleration. What is the meaning? If the frequency is very high, frequency is very high means if wave is moving like that and another wave is moving like that, so for traveling that much distance, if L, here is also L, the both distance is similar, so here the cycle number of cycle is high, here the number of cycle is less if we compare to both. So this, that is your case 1, if case 2 having the more frequency. If the frequency is higher, if you will see, your wave, your the water surface is behave like that is cycle will complete in the very less time. So what will happen? Definitely oscillation will be more. Your the therefore what will be happen? Higher local velocities and acceleration. Definitely if the cycle will more for traveling the more similar length if we compare to case 1 and case 2. So definitely in second case acceleration and velocity will be influenced more. So now moving ahead on the next question, what does the group celerity represent in the wave theory? Group celerity, here we are talking about the speed of individual wave crest, the speed at which wave packet propagate, speed of wave troughs, speed of wave energy dissipation. So please think on that. The group celerity, the speed at which your wave packet propagate. So this is wave packet. Here we are talking about wave packet propagate. There are lots of wave here, not only single wave. So explanation is what? If you will see very carefully, speed at which wave packet propagate. Option B is correct. But explanation, group celerity represent the speed at which wave packets consisting of multiple wave of different frequencies and wavelength propagate through a medium, and it describes the overall movement of wave energy. Now, at which point is the pressure under progressive wave maximum? Here we are talking about progressive wave. What is the progressive wave? Standing wave. We'll see one question I think I have. So whether on crest, trough, half between the crest and trough, bottom of the ocean. Think on that. Which one will be correct? So definitely it will be maximum on the wave crest. What is the wave crest? Wave crest is this. Why? Because of your particle, here the explanation, the pressure under progressive wave is maximum at the wave crest. This is because of the wave particle are displaced upward at the crest, resulting in increased pressure due to the weight of the water above. Remember. Now moving ahead, next question, what is the relationship between wave energy and wave height? Here we are talking about wave energy and wave height. If your wave having this much energy, let's suppose 10 unit, what will be the height of your wave? How you will calculate? Because these are the relation you can utilize for applying your boundary condition in the calculation of wave theory. Whether the relation linear, quadratic, exponential, inverse. Think. I have one slide. This is the potential energy. Wave have the kinetic energy. The relation between this, your wave height as well as wave energy. Is the quantity type. So option B is correct for that. The relation between wave energy and the wave height is quadratic. Wave energy is proportional to the square of the wave amplitude, that is your wave height. Wave amplitude is nothing but your wave height, and indicating that the energy increase significantly with increase in the wave height. Now moving ahead. What determines the phase speed of wave? We are talking about here the phase speed. Remember, wave amplitude. What determines the phase speed of the wave? Wave amplitude, wave frequency, wave depth, or wavelength? Wavelength. So the wavelength determines the phase speed of the wave. How? The phase speed of the wave is determined the wavelength of the wave. It represents the speed at which individual wave crest propagate, and it inversely proportional to the wavelength. Remember. How is the wave frequency related to the wave dispersion? Wave frequency and the wave dispersion. Let's suppose if we represent the dW, how it relate? The higher frequency leads to the lower dispersion. Lower frequency leads to the lower dispersion. Higher frequency leads to the higher dispersion. Frequency does not affect the dispersion. Anybody join? No one joined till now. So the answer of this question is the higher frequency leads to the higher dispersion. How? The wave dispersion refers to the phenomena where the wave of different frequencies travel at different speed. Higher frequency wave experiences greater dispersion, leading to a more significant separation of wave components. If you will think in your mind, you can visualize if the frequency is more, that is the number of cycle is more, and for a particular time of travel the same distance, think like that, definitely your dispersion will be greater. What term describes the speed at which the envelope of wave group propagate? Phase speed, group celerity, wave frequency, wavelength. Here we are talking about envelope of waves group. That is your group celerity. We were discussed previously also. The group celerity represents the speed at which envelope of wave group propagate through a medium. It describes the movement of overall wave packet formed by a superposition of individual waves. Which equation governs the conservation of mass in fluid? This is the basic question from the fluid mechanics. Whether the Bernoulli, Euler Laplace continuity. Please think, or you try to write the all equations. What are the Bernoulli's equation, what are the Euler equation, Laplace equation and continuity equation for your, you can always try to remember all these things. So if you will write here, always try to write whatever you are not able to remember, then try to write again and again, then you can easily remember the things for a long time, not the for uh, I mean long time means for 1 month 2 month you can remember, after that if you will not revise anything you can forget. But concept sometimes people remember, but expression you cannot remember. So I am looking your Euler equation. So basically if we, let me tell something very important thing here, because it is last class for the your fluid mechanics. So if we think on the your Newton's second law, force is equal to mass and acceleration, or you can say the change in momentum divided by, like that. So in force, if you are going to consider the your Euler, you will consider what type of force here, your pressure force here you will consider, and you will consider body force. But when you will derive your Navier-Stokes equation, you will consider pressure force, body force, and these are the main force, and also your viscous force, that is your viscosity part or shear. So these are the basic difference here. So whatever I was writing previously, your equation, the Euler equation, where is the, yes, here. If you will remove these things from this equation will become as a Euler equation for that much. After putting the assuming the lots of assumptions, we will get the final expression like that. So remember, now moving ahead, this thing I want to talk. What are the questions? So here definitely is the continuity equation, but let me go on the question. Yes, conservation of mass is nothing but your, if you will, conservation mass, simply we will write what, for steady incompressible flow is nothing but your mass rate inflow is equal to mass rate outflow, and we, for derivation, we will consider the control volume is fixed. If control volume is moving, control volume is deformable, so this is not the final continuity equation. So how you will, what is m dot in and m dot out? If this is section 2 and section 1, rho av a1 v1 is equal to rho 2 a2 v2, but if control volume is not fixed, so how you will go through? You remember the RTT, Renault transport theorem, d by dt of control volume of B control volume rho dA rho dV plus mass in and mass out. So here, if your control volume is fixed, the change in the change in your control volume will be the 0. So from here we will get the mass in is equal to mass out for the steady and incompressible, because here the steady, so a steady thing, your time will be 0, the differentiation with respect to time will be 0 of your control volume. So mass in and mass out will go. So remember this thing. If you want to go in the more deeper, so you can mail me also. I will maybe I can upload one video regarding that also. So let me write my mail ID, not op Maurya IIT14 @gmail.com. So you can mail me also. Now moving ahead on the next question. What term describe the time rate of change of wave height? Time rate of change of wave height. Wave amplitude, wave frequency, wave steepness, or the wave slope. So here also screen is visible, so you very visible. So option C is correct. Wave steepness represents the time rate of change of wave height. Wave steepness refers the ratio of the wave height to the wavelength and describe the degree of slope or steepness of the wave profile. Now the next question is, in which direction do water particles move in the progressive surface wave? In which direction do water particles move in a progressive surface wave as it phase? Circular motion. In circular motion, here is talking about in which direction do water particles move in a progressive surface wave as it phase. If the phase is circular, linear motion, up and down motion, stationary motion. So definitely it will be in the circular motion. So water particles in the progressive surface wave move in a circular motion as the wave pass through them. This motion becomes smaller with the depth and negligible below the wave base. So sir has also explained, I think, on that through the pictorial representative. If you want to see, please go through the lecture. Now the next question is, which factor primarily determine the wavelength of wave in deep water? Wave amplitude, wave depth, water depth, wave frequency and the wave salinity. Which factor primarily determines the wavelength of wave in deep water if the water is very very deep? So wave frequency. In the deep water, the wavelength of wave is primarily determined by its frequency. It is inversely proportional to frequency. Meaning higher frequency wave have shorter wavelength. Definitely. If the frequency will be high, definitely your wavelength will be shorter. Next question is, what term describe the maximum vertical displacement of water surface from its undisturbed position? What term describe? Wave frequency, wave height, wave amplitude or the wave period? Very easy question. Wave amplitude definitely. Explanation: wave amplitude represents the maximum vertical displacement of water surface from the undisturbed position and it is measure the wave intensity. Yeah, it's correct. Now moving ahead, what phenomena occur when wave approach a coast and bend due to change in water depth? Please remember this question because this is very practical. That is the option is wave fraction, wave refraction, wave reflection, wave diffraction, wave transmission. Which one? You please think on that. What phenomena occur when the wave approach a coast? Suppose this is a coast. If this is the coastal line, let's suppose this is the Bay of Bengal. So if the wave approaches the coastal line, what will approach a coastline and bend due to change in water depth? This phenomena is known as what? Because here is come and bend like that, bend like that, bend like that, come like that and bend like. So this phenomena is known as what? This phenomena is known as wave refraction. Remember always. So this is a general question. So wave refraction is a bending of wave as they approach a coast due to change in water depth, and this phenomena is caused by the variation of wave speed caused by the change in the depth. Now moving ahead on the next question, which term describe the time it takes for one full wave cycle to pass a fixed point? Hello? Hello?
Hello, sir.
Yes, I am audible, please.
Yes, sir. Yes,
Yeah, okay. Okay, and slide is visible? Question
yes, sir.
answer? Okay, okay. Oh, that's good. Oh, actually, I have solved the several question. Okay, let me go through. So, we have solved actually many questions. So, today I have not gone through the theoretical part. So, from starting from the assumption from the linear wave theory. So, basically assumption is nothing but your amplitude should be less than the linear or depth of the water flow. So, these are the things if you will go through the video you can find out. And what are the equation? These are the basic question. And which equation governs the behavior of your velocity potential in the linear wave theory? So, basically the Laplace equation you can find out here. So, these things is important. and now these are the things is very easy. Not here, I think I have discussed some very conceptual things. What is the celerity in the context of wave? Celerity is nothing but the speed at which the wave crest is propagated. So option B is correct here. So actually celerity is nothing but your the velocity of wave minus your the velocity of medium. So velocity wave actually contain what? Velocity wave will be contain your whatever you have given the energy on the water surface in terms of disturbance, that velocity as well as your the medium velocity. This VW is contain both things. So when you will minus the your medium velocity, then you can easily calculate the wave, that is the velocity of wave due to the whatever you have given the energy on this water surface. So here the explanation is very important in this. It represents the velocity of energy transport associated with the wave motion. So these are the things is very easy. Group celerity we have also discussed. So group celerity is nothing but the speed at which the wave packet is propagated. So these are the things. For sake of your understanding, the amplitude is this one. Sometimes we know also the height of your wave, and your length, that is the wavelength is this. Sometimes wavelength consider from here to here also, remember. And the relation between your energy and the height of your wave is quadratic. So these are the things we have discussed already. So now moving ahead, here I have discussed some RTT, the Renault transport theorem, how your continuity equation form for your the control volume, if the control volume is fixed, if not control volume is fixed, how you will, because why? Because here the one question was about some very basic question, which equation wants the conservation of mass of the fluid. So if you want more information on that, you can please mail me also. I can upload video, separate video on that. So these are the very basic question. So now I am on the question number, yes, here. So which term describe the time it takes for one full wave cycle to pass the fixed point? So this is nothing but your wave period. And these are the some basic question I have taken, because of the these are information will help you for considering the boundary condition when you solve the wave problem or the wave propagate problem in the water or in case of the fluid. So explanation is wave period is the time it take for one full wave cycle to pass a fixed point, and it is inversely proportional to your wave frequency. So this is your wave period. So now moving ahead on the next question, this is very important question. What is the primary mechanism responsible for energy dissipation in breaking waves? Wave reflection, wave diffraction, or turbulent mixing? So please think, very easy question, not very tough question. So you can write in the chat box also the answer of the question. So the primary mechanism is nothing but, here the primary mechanism is the turbulent mixing, which is responsible for the energy dissipation in the breaking wave. So how the energy dissipation in the breaking wave primarily occur due to the turbulent mixing within the wave boundary layer. Remember, as the wave crest collapses and breaks. Now, which term describe the horizontal distance between two successive wave crests? So this is very basic question. Wave amplitude, frequency, wavelength, and period. Definitely it will be the wavelength. So what is the definition of wave? This is a very basic question. A disturbance that carries energy through a medium or a space, the disturbance that only occur in fluid, the disturbance that remain stationary in medium, the disturbance that carries matter through a medium. So which one is correct? Please, if you want to give answer, please just write within 1 minute. Otherwise, I will show the answer. Basic question is the what is the definition of wave? The disturbance that carries energy through a medium or a space. Whether option A, B, C, D, which one is correct? If you want to write within 1 minute, please write. After this question, I will take 5 minute break. Then I will come back. So tomorrow I have also class from 6 to 8, 2 hour extra session. In that session, I will solve the lots of problem from starting from beginning to last. Very basic question, very informative question. So please, if anybody want to join, please. If you will join, definitely it will be very helpful on the final exam or another exam, state exam or your university exam. So the answer of this question is not very. So option of this question is A. The disturbance that carries energy through a medium or a space, not matter. Not option D. So the explanation is what? A wave is defined as a disturbance that carries energy through a medium or a space. This disturbance can propagate through various mediums such as air, water, solids, and can exhibit different properties depending on the type of the wave. Now the next question, basic question. If you want to give the answer, you can give. What is the difference between transverse and the longitudinal wave? I will take 5 minute break. So the question is, what is the difference between the transverse and the longitudinal wave? So the transverse wave propagate energy perpendicular to the direction of wave motion, while the longitudinal wave propagate energy parallel to the direction of wave motion. Transverse wave cannot propagate through fluids, while longitudinal wave can. The longitudinal wave have a higher frequency than the transverse wave, and the transverse wave are only found in solid medium, while the longitudinal wave are found in the all medium. These are the basic question from the wave. So definitely option 1 will be the correct. Energy, propagate energy perpendicular the direction of wave motion, while the longitudinal wave propagate energy parallel to the direction of wave motion. So now the next question is, what is the relation between the frequency, period and wavelength? We are talking about f, your t and wavelength lambda. So frequency is reciprocal of the wavelength. This is telling f is the reciprocal of wavelength and period is reciprocal of frequency. Frequency is reciprocal of period and the wavelength is reciprocal of frequency. Here is the sign is that this is f. So like that, the frequency is the product of wavelength and period. Frequency, period and wavelength are unrelated. So which one is correct? Frequency, period and wavelength. If your period will be very high, then definitely your frequency will be. If your period will be very high, wavelength, now I have given the hint. So here is the relation if you want to see. Frequency is reciprocal of period. If you want to see, if your period will be more, definitely your frequency will be less. The wavelength is reciprocal of frequency. If frequency will be very high, there is a frequency very high, then your wavelength will be very less. If frequency will be very less, if we compare these two things, then your definitely lambda will be. So what is actually frequency? Frequency is a number of wave cycle passing a fixed point per unit time. If you want to see at that point how much wave cycle is passing from this point per unit time. If the more cycle is passing per unit time, so definitely your frequency will be high. If the just you can understand. And the period t is time taken for one complete wave cycle to pass a fixed point. So period is nothing but how much your wave is taking to pass one cycle from a fixed point. So definitely if it will be pass very in short period, then what will be happen? Your frequency will be very high, because number of, here in frequency is related to number of cycle, and your period is related to one cycle, just one cycle is complete pass through the. So remember, wave velocity. What is wave velocity? The speed at which energy move through a wave, the speed at which wave move through a medium, the speed at which particle in a medium moving during a wave, the distance between two successive wave crests. Wave velocity. The speed at which energy move through the wave, the speed at which wave move through a medium, the speed at which wave move through a medium. That is your wave velocity. What were we have? I was discussing previously VW. That is a combination of your medium velocity plus the velocity due to your whatever you have given the disturbance, the energy in terms of disturbance. Now the next question is, what is the difference between phase velocity and the group velocity? So here is the phase velocity refer to the speed of individual wave particle. Phase velocity is related to individual wave particle, while the group velocity refers to the speed of wave packet. So group means wave packet, remember, and here is the individual particle of wave. So the next question is, in linear wave theory, what is the velocity potential actually? This is very important. In linear wave theory, what is velocity potential? The potential energy associated with the velocity of wave particle, the function used to be describe the variation of wave height over time, the function used to describe the velocity of fluid particle in wave, the scalar function whose gradient gives the velocity field in the fluid. Which option is correct for the this question? So if you want to give answer, please within 2 minutes try to give the answer. You can write in the chat box whether option A, B, C, D correct. So the answer of this question is, if you want to see, in linear wave theory, what is the velocity potential? Phi, whatever sir has discussed about your Laplace equation solution in terms of velocity potential function. If you want to see in the here, you can see, I think, lateral boundary condition, not here. Sir has discussed about yes, here if you will see the solution of the Laplace equation in terms of your potential function. So please follow this, these are the slides. If you will follow from the above to some bottom slide, then you can easily understand what is the significance of the potential function in the linear wave theory. So but here the question is, the potential energy, what is the velocity potential? The potential energy associated with the velocity of wave particle, okay, the function used to describe the variation of wave height over time, that is a function which is used to describe the wave height over time. This type of function, the function used to describe the velocity of fluid particle in wave, that is a function of your wave particle, the velocity of wave particle, or the scalar function whose gradient gives the velocity field in the fluid. Gradient means what? That is, gradient means x direction, in the phi y direction. This is how your function change with the x direction, how as x is changing, how your function change with the as y is changing. So this is the your gradient. So whether it will u, v, whatever the notation, whatever the sign, not mean. So this is the correct option. Number D is correct. It is a scalar function whose gradient gives the velocity field of your velocity field of the fluid. So explanation is what? In the linear wave theory, the velocity potential is a scalar function that, when differentiate with respect to a space coordinate, yields the velocity component. Differentiate with respect to the space coordinate means what? Delta x dx d phi by dy. So this is telling component of the fluid flow. It often used to describe the motion of fluid particle under wave action. Remember always. So what is the difference between progressive wave and the standing wave? It is also very easy. So option a wave progressive wave moves through a medium, while a standing wave remains stationary. A standing wave moves through a medium while a progressive wave remains stationary. The progressive wave only occur in solid while the standing wave only occur in the fluids. The progressive wave have higher frequency than the standing wave. So as name suggests, the progressive wave moves through the medium and a standing wave remains stationary. Not stationary means not here the meaning of the stationary, because your stationary wave, I think I have some explanation. Yes. Option A is correct for that, but the explanation is a progressive wave is one that propagates through the medium and transferring energy from one point to another point. Here the energy transfer is happening in the progressive wave. In contrast, a standing wave is a wave pattern that appear be stationary. Wave is happen in the system, but it will be appear like stationary, not the stationary. Wave is not stationary, appear like a stationary and does not propagate through the medium. That is, the energy does not transfer. What is wave soiling? This is also important. A process of wave breaking near the shore, the process of wave bending as they approach the shallow water, the process of wave energy dissipation, the process of wave reflection of a boundary. Wave soiling. Think little bit within 1 minute if you want to give answer. So wave soiling is nothing but it's the bending, that is the option B is correct. uh, Wave soiling refers to the progress in which wave changes their characteristics such as wavelength, wave height as they approach the shallow water. This occurs due to the reducing of wave depth and causing the wave to slow down and bend. So option B is correct for that, and ultimately leading to the wave breaking near the shore. Shore line you always remember, if any the coastal line, like here is the water up to that much, suppose the Bay of Bengal, so up to the coastal line you can, and this line is known as the shore line. There is also the ground is there, but up to that, if you will draw a line up to the your water, up to that much is water will be touched on the ground. So this is your shore line. So here your wave will be bent because of the wave depth will be reduced and wave slow down, definitely your wave will be slow down. So one question is very important. If the wave frequency is 2 hertz, f is equal to 2 hertz, speed is also given 10 meter per second, what is the wavelength of the wave? Lambda you need to calculate. Previously I have shown the formula also. So if you want to give answer within 2-3 minutes, please try to give the answer. Very easy question. So the answer of this question, the relation between your frequency and velocity and the wavelength is nothing but your velocity of the wave, speed of the wave is equal to your frequency into your lambda. So if you will calculate, it will be comes out. No, not. Sorry for that. Your relation between the your yes, it's okay. Velocity is equal to frequency and lambda. But in the question is asking the lambda. What is the lambda of that is the wavelength. So wavelength is nothing but your velocity divided by frequency. So velocity is 10 and your frequency is 2. It will comes out here 5 meter. So correct. So here is some solution I have given also. So now very basic here question. A water wave has a period of 8 seconds. What is the frequency? So this is also very easy. If you want to give answer within 1 minute. So here you know already the relation between your frequency and time is nothing but 1 by t. So if you will calculate what you will get, definitely you will get 1 by 8 and it will come around 0.1 by 8 and if you will calculate point 0 will come and 8 ones are 1, 2, 5 it will come. Now the next question is, here is the very important question. Water depth is 5 meters, that is y is given you 5 meters, or sometimes you can say height of the water, and the wavelength is 10 meters. What is the phase speed? If you want to calculate phase speed of the wave, phase speed is nothing but the speed of individual wave particle. group. I think one question we have discussed already on that, the phase speed and the group speed of the wave. So please try to give the answer of this question. Very easy question. Within 2-3 minutes if you want to give. So your phase speed formula is nothing but it is the your just if you want to remember your salinity formula. Actually, if you want to read here, the phase speed c of the wave in deep water is given by c is equal to gd, where g is the acceleration due to gravity and d is the water depth. So if you want to calculate here, here was the your c is nothing but root under gd. Here the your lambda was, that is your wavelength is given 10 meter, is not utilized for the calculation of c, just for confusing. So g is 9.81 and d is nothing but 5 meters. So you will get approximately 5 meter. How much you will get actually, let me calculate. Your 9.81 into 5, it will come 49.05. Definitely root under 49.05, definitely will come 5 meter per second. Now moving ahead on the next question. What is the dispersion relationship of deep water waves? What is the dispersion relationship for deep water wave? So this formula you can see also in your open channel flow, your wave celerity. Your wave celerity is nothing but c is equal to what? With the lots of assumptions, gd. D is nothing but area by top width. In case of open channel flow, if the very wide channel and all, then your D will be become Y, that is the depth. Definitely here it will, due to this criteria, huge CD. So you will be correlate from your open channel flow expression. Also, definitely here we are talking about the wave celerity in terms of C, definitely very wide. So also you know the Froude number, that is your V by rule ZD. So nothing but your FR is also your velocity, average velocity basically. Always remember average velocity divided by your wave celerity, you can say also. With the assumption for getting the expression of this, we have assumed lots of things. You need to follow the book. Now the question is, what is the dispersion relationship for deep water waves? We are talking about here the deep water waves. Option: V is equal to G by 2 pi T. T is the time period. Option B, V is equal to, V is the velocity of, let me write here, velocity of wave, root gt. V is equal to not T. T here I was talking previously here, T was the tau wave, but not here the tau wave. This is the time period. And option C is velocity is equal to gt by 2 pi. Okay, let me gt by 2 pi. Option D is equal to G by 2. Which option is correct for this? The dispersion relationship for deep water waves. If you want give answer within 2 minutes, please. So the answer of this question is your root gt. T is the wave period or time period, time wave period. The expression relationship for deep water wave relates the wave speed u and wavelength and the gravitational acceleration through the formula. This remember. Now this is the last question for today. And what is the formula for calculating the wave energy? Whether option A, E is equal to half rho A square V square, E is equal to half rho G A square, E is equal to half rho G square A square, E is equal to half Rho AV. Which one is correct? Whether A, B, C, D, which one? Try to give the answer of this question. Very easy question. Even if you not know the formula, then you can go through some trick and you can give the answer. So the answer of this question is your the formula for calculating the wave energy, actually the half rho a square v square. The option A is correct for that. The formula for calculating this, the rho a v square, or rho is here your density of medium, a is the amplitude of the wave. Whatever the amplitude of the wave, this is the amplitude. So unit in meter, amplitude, the velocity of the wave, meter per second. If you will find out the your expression using the dimensional, put the dimensions of all these things, kg per meter cube, a is meter, so meter is square. A is here is not area. I was thinking this is area, but this is correct, not correct. So A is the amplitude and V is meter per second, but here is a square, so we will put these things. So kg per meter cube, yes, then meter square, then again meter square divided by second square. So here what will happen? Here kg meter power 4 divided by meter cube second. So this expression, what is the expression? Kg meter power 4 divided by meter cube second square. So if you will cancel out, it will become like that. We are doing somewhere mistake. Kg per meter cube, meter square, meter 4, definitely. Yes. So kg into meter per second, meter per second square. So this is your Newton. But here is talking about the formula of calculating the wave energy. So if you want to calculate the wave energy, the formula of the energy is nothing but, if you will talk energy, have the your Newton meter. This is the dimension of energy, but I think it is not related to here. But for calculating, you always remember, for calculating the wave energy, you need to apply this formula. E is equal to half rho a square v square. Okay. So maybe this is per unit length. Whatever the formula is there, this is the energy per unit length. Energy per unit length of the wave. Then it is correct. Remember. Okay, so for today, that's it. We'll meet again tomorrow. If you have any, Ratnasiri, if you have any specific question related to your any week of the hydraulic engineering, so please you can mail me if you want ask any question. Otherwise, we will solve tomorrow lots of question from your first class to maybe up to the 10th class or 12th class. That is a 12 week. So I have collected the some very easy to little bit difficult questions also, theoretical questions, numerical questions. We will solve tomorrow. Okay, thank you for today.